let's show homogeneity of a function of two variables. This function of two variables, f, takes an ordered pair x, y, and gives out 3 times x plus 2 times y. So I will look at a particular input, the input 1, 2, the thing in the domain of f, 1, 2, and I'll look at the particular scalar 3, and examine f of 3 times 1, 2, and 3 times f of 1, 2. Remember that function is homogeneous if for any element x, and now let me promote that x to an x vector of its domain, and for any scalar c, c times x is c times f of x. And so the particular x that I have in mind is 1, 2, the particular c I have in mind is 3. Okay. Now the characters involved in the story will be x, now a vector, and f of x will be a number. In blue, we'll have c times x, that's a vector. C times x is a vector, so f times c of x will be a number, and c times f of vector x. And if we're going to show that this is homogeneous, we need to show that this equality holds for arbitrary c and x. Okay, so I'm looking at a particular case, everything worked out. 21 in both cases, and I'll draw this as I've been doing in the other examples. Now x, the vector 1, 2, I've drawn here, and 3 times that, cx, I've drawn here. It's the vector 3, 6. You know what I just realized I did? I did that backwards, didn't I? So that is to say the component's 3, 6. Yeah, so here I drew the vector 2, 1 as opposed to, okay, so what I've got to do is make the axes the way that I want them. This is the y-axis and this is the x-axis. See how I fixed my problem there? I did the horizontal axis as the y-axis and the vertical axis as the x-axis. That way 1, 2, that means that the 1 right there is supposed to be an x value, and that's why this x vector is only up 1. X vector is supposed to be the vector 1, 2. And its second component is 2, which should be a y value, so we go to the right 2. I hope that you're okay with that. I hope you've become fluent enough over the years, or, well, through just a small part of 21C, actually, to be able to exchange your axes like that. If you don't like it, redraw it with this, the x-axis, and y-axis. It'll look like the same picture flipped around like this. I apologize. Now, continuing, I want to draw the thing that f takes 1, 2, 2, and that's 21, isn't it? So no. F of 1, 2 is 3 times 1 plus 2 times 2. That's 7. So I need to go out to 7 here. And this arrow is f of x. And I also want to get a blue pen and see what f does to cx. That f of cx is 21. So I'll draw an arrow going out to 21. Okay. And that is f of c times x. And in red, I draw this other guy at c times f of x. Now, f of x is 7, and c is 3, so 3 times that would be 21 also, so I draw a third line in red all the way out to 21. Fatten him up like this so you can see him. And that, with its tip at exactly the same place at 21, is c times f of x, and indeed they're the same thing. Now that we have this drawn for a particular pair of vector, a 2 vector 1, 2, and the scalar 3, let's construct the argument that this function f is homogeneous. Okay. So for an arbitrary 2 vector, and for some reason I was thinking I needed two vectors. It's another senior moment. So for an arbitrary 2 vector x1, y1, and arbitrary number c, f of c times x1, y1 Well, okay, a scalar multiplication of a 2 vector looks like this. And then we're ready to take the first component, second component, and replace them for x and y respectively there. 3cx1, 2cy1. And we're going to compare that to c times f of x1, y1, this arbitrary vector. Then that'll give c times 3 times the first component plus 2 times the second component. And distributing, we get exactly the same thing. Now, I can wrap this up by saying, thus, f is homogeneous. When you're new to this kind of writing, you have the desire often to say things like, so, since for an arbitrary vector x1, y1, and for an arbitrary number c, f of c x1, y1 is equal to c times f of x1, y1. I mean, why would you add that additional thing down here? It seems kind of redundant. You'll accidentally write things in a redundant fashion many times when you first get started writing about a topic, but that's not a bad thing. As you go on and get more sophisticated in your writing, you become more literate, you become a better writer, you become more succinct. It's practice that's going to lead to that, not immediately knowing exactly what to do. And I hope that I've shown some variation as I've been going through these examples in how I write things. Because it's not that there's one thing that you have to write first and then another thing you have to write second. You just need to speak coherently about these and actually show that the function has this property or does not have this property. And I hope all that's coming through. All right, on to showing that some function of two variables is not homogeneous.